Welcome back to Mr. DuPage's classroom. This lesson is for my General Algebra 2 class. This is 2.2 Day 3, Graphing Quadratics in Standard Form. Example number 1 is just like we did a couple days ago and yesterday when you practiced. Alright, so what we need to do first is find our A, B, and C values. Our A value is just going to be 1, because remember, any time that there's no number in front of an X, it will just be 1. B would be -4, and C would be -12. Okay? Step 2 is to figure out whether this will open up or open down. Well, in this case, my A value is positive, so it will open up. Okay? Step 3 is to find the axis of symmetry. In order to find the axis of symmetry, we need to find our x value for our vertex. So my axis of symmetry, if you remember, is x equals the opposite of b over 2 times a. Well, the opposite of my b value is -4, so its opposite would be +4 over 2 times my a value is 1. So it would be 4 over 2, which is 2. So my x value in my vertex will be 2. In order to find my y value now, I'm going to take 2 and plug it back into the original equation for that x and for that x. Okay? So my y would equal 2 squared minus 4 times 2 minus 12. If I type that straight through in my calculator, which you can do, I'll end up with -16. So my vertex is 2, -16. Okay? My y-intercept is the next thing we wanted to talk about, is the y-intercept. Well, my y-intercept is just going to be 0, comma, my c value, which is -12. All right? Finally, we need to make a table just like we have since day 1 of vertex form. So I have my x value, my y values. 1, 2, 3, 4, 5. Okay? I will put my vertex in the center. It is 2 for my x. It is -16 for my y. To fill in my x's, I will add 1, which is 3, add 1, which is 4. I will subtract 1, that's 1, subtract 1, so 0. Now, we already know what our y-intercept is, so when x is 0, my y would be -12. Anytime that I have a 0 in my table for x, I can just plug in my y-intercept. So the only thing I have left to find is when x is 3. Well, how do I find when x is 3? What is my y? Well, y would equal, I'm going to take 3 and plug it in for my x and my x. Okay? So it would be 3 squared minus 4 times 3 minus 12. Type that straight through in my calculator, and I would end up with -15. Since all quadratics are symmetrical, I can just fill in that other blank. All right? So now I need to plot my points. The first point was 2 and -16. So there's a point there. That is also my axis of symmetry. So I need to remember to put our dotted line. The next point is 3. -15 would be about halfway up, so there. Then I have 4. -12, which is going to be here and there. Go ahead and connect all my points. I do have a U. It does open up just like we said it would. And there we are. The last thing we need to do is our domain and range. Our domain is always double-bar R, all real. And our range will be Y. Since it opens up, it's going to be greater than or equal to my y value at my vertex, which is -16. You do need to have all those steps in there. I need to have my A, B, and my C. I need to say whether that opens up or down. I need to have my axis of symmetry. I need to have my vertex, my y-intercept, my table, my domain, and my range, and I need to graph it. Okay? You need to know how to do all those steps. Now on to story problems. That first problem was just review. Example number 2, we need to figure out a soccer ball is kicked into the air. The path it takes can be modeled by the function f of x is equal to negative 16x squared plus 32x, where x is the horizontal distance in yards. What is the ball's maximum height and how far will the ball travel? Well, if you think about a soccer ball being kicked, it's going to start up going up in the air. It's going to get to a certain height and come back down. So my vertex will be this top point. That's going to be my vertex. So in order to find the ball's maximum height, it will be my y value at my vertex. In order to find the y value at my vertex, I need to find my x value first. So again, my x will equal the opposite of b over 2 times a. Well, the opposite of b, my b in this case, is positive 32, so it would be negative 32 over 2 times negative 16 because my a value is negative 16. Okay? Negative 32 over what's 2 times negative 16? That would also be negative 32. So it would be positive 1. In order to find my y value, I will take positive 1, plug it back into the equation. So y would equal negative 16 times 1 squared plus 32 times 1. If I type that straight through in my calculator, I'll end up with positive 16. The other thing I need to figure out, so knowing the y value at the vertex tells us what the ball's maximum height would be. So the ball's maximum height is going to be 16 yards. Now, how far will the ball travel? It wants to know the total distance, so the point over here that the ball will travel. That is when my y is 0. Okay? The first point is where the ball was kicked from. My starting point was here. Okay? That's where the ball was kicked from. It's going to travel up like this, hit through my vertex, and come down at this point. Okay? So when I make a table, I will have 2 locations where y is 0. Let's go ahead and make our table and look at that. All right. My vertex goes in the center, so 1, negative 16. Going to the right, I would add 1, so 2, add 1, so 3. And on the left, subtract 1, so 0, subtract 1, negative 1. I'm wanting to find the point. One of these locations should have 0 as my y. So what am I going to do? I'm going to plug 2 in for my x values. So if I plug 2 in for my x values, it would be negative 16 times 2 squared plus 32 times 2. Type that straight into my calculator. I'll end up with 0, which means this is 0. Remember, x is the horizontal distance that the ball has traveled to begin with. So the first x, this one here, at 0 and 0, that is when the ball has not traveled anywhere. So that y being 0 will not be our answer. Our answer will in fact be this 2, because that's when the ball is at 0 height again. So the distance traveled, I'm going to erase some of this real quick. The distance traveled would be 2 yards. Okay? Example 3. An airline sells a 3-day vacation package. Sales for this vacation package can be modeled by the quadratic function S of p equals negative 40 p squared plus 32,000 p. Sales are dependent on the price, which is p, of the package. If the price is set too high, the package won't sell, but if the price is too low, prospective buyers will think it is a scam. At what price does the company have the greatest revenue? In order to find the greatest revenue is talking about price, or my p value. So it's going to be my p, or my x, however you want to think of that, at my vertex. Okay? Because just like on the soccer ball problem, if I have price, or the cost on the bottom here, and total revenue on the top, so revenue price, at some point it's going to be at 0, 0. It's going to go up to a certain height. It's going to come back down to 0, 0. So we're looking for this point right here. That would be the highest revenue, and it'd also be the highest price, or the best price for the company to sell their package at. Okay? So I need to find the P, or my X value, at the vertex. So P would equal the opposite of B over 2 times A. My B value is 32,000. So it'll be negative 32,000 over 2 times negative 40. So that'd be negative 32,000 over negative 80, which equals $400. So the best price for them to sell their package at is $400. What is the maximum revenue, or the maximum sales that they could possibly have with this? This would be our Y value at the vertex. So I'm just going to take my 400, put it back in for P. So it'd be negative 40 times 400 squared plus 32,000 times 400. Type that through my calculator, and I will end up with $6,400,000. Okay? That is the lesson. So remember, when you're looking at story problems, depending on what kind of story problem you're looking at, if you want to know, like in example number 2, we were looking at X is the horizontal distance in yards. If you want to know how far the ball traveled, it will be when Y is at 0. If you want to know how high it got, because Y in that case, or f of X, was our height, then we are looking for the Y value at the vertex. Example 3, it's talking about what price, so that was the P. I would find the P value at the vertex. And then it asked about the maximum sales possible. Well, that would be the Y, or the S of P, at the vertex. Or, yes, at the vertex. Well, that is the lesson. Thank you for watching this video, and have a great day.